Okay, so again, in solving for your problem, you have isentropic efficiency for your turbine as well, which gives you 0.8.5, right? So you make use of this isentropic efficiency at your turbine, which is the actual work divided by isentropic work. So you plug in all the values given. So T3 is already given to you. T4S is already you already have the value over here. So T4A is the one that you are trying to look for, right? So when you rearrange these equations over here and you fill in all the values, so you are going to have T4A is equal to 974.06 Kelvin. Alright, now that you already have all the temperature value, as you can see here, you already have your T3, T4A, T2A, T1, and also T2S, and T3, again T4A. So we are going to make use of these equations that we have now to solve all this part B, C, and D. Alright, so when we obtain the value of T4A, we actually have solved for the A part. Now we are moving to B part, where you need to find for your work net. So it's actually the work of your turbine minus with your work of compressor. So you make use of your turbine work, right? Which is your turbine work is happening at T3 and T4. So if you have a look at here, this is where your work of your turbine is happening, right? So that's why we are going to have T3 minus T4 for your B part. And also you will see that for the work in, which is your compressor, is happening at this part. So this is your work in, this is your work out, or in other way, this is the work at your turbine, and this one is the work at your compressor. Okay. Alright, so rearranging for the turbine over here and compressor over here, and next you fill in all the values, right? So you are, at the end of the day, you are going to get this value for your work net. Alright, so once you got your work net, now it is easier for you to find your thermal cycle efficiency, right? The first thermal cycle efficiency. So you are going to make use of work net that you have over here. And what about your Q in? Q in is actually the process that happens during the combustion, which is from 3T to 2A. So let's have a look at your TS diagram previously. So if we have a look at here, this is where the combustion process happened. So you are going to take the actual value and also the T3 value. Hence, when you plug in all this value for T3 and 2A and also your CP, you are going to get Q in is for 981.01 kilojoule per kg. And next, what you do is that you fill in your value for your work net, which is this one, and also value for your Q in, where you got from this one. So when you calculate, then you will have 30.95% for the overall thermal cycle efficiency. Now finally, we are going to solve for your D section, where you were asked to find the new thermal cycle efficiency given that your compressor, right, is working 100% in 100% conditions, right? It doesn't have any losses. So what does it mean? Let's have a look at your TS diagram back. So for this part D over here, what it means is that your compressor is working at 100%, right? So you don't have this T2A value over here. Okay, you don't have this T2A value. Okay, meaning that your compressor over here is working at 100% efficiency, whereas your turbine over here is still remain at 82% efficiency. Okay, so we are going to calculate what is your Q in, right? Your Q in is here, and also your work in by making use of T2S value only, right? So let's have a look at how we are going to do that. Alright, so first we still make use of the same workout, which is T3 and T4A, right? But now for your work in, you are going to make use only T2S because the 100% working condition, right? There's no losses. And also we are going to have T1 over here. So you plug in all the values, it will give you the new work net this much, right? So it is very different with the work net that you obtain in the first part over here. So this one you got 303.58 kilojoule per kg because you are considering T2A. So now that you gain new work net, you also need to find your new Q in because you are considering T2S now. So this is your new Q in value. So you plug in both numbers into these equations, it will give you the new thermal cycle efficiency, which is 34.53%. So if you have a look at your previous section C, okay, you will see that your efficiency is 30.95%, right? And when you move to this part over here, the new thermal is 34.53%. So it is an increment of compressor's efficiency contributing to the increment about 35.5%. So how do you do that? It's actually 34.53 you minus with that 30.98 something, right? So we get about 33.5% increment, right? So the overall thermal cycle efficiency improve, right? Because of your compressor, work of your compressor is working 100% efficiency. There's no losses, right? So we have completed all the questions inquired. I hope you will be able to try out this problem on your own, and we will see you in the next example for Brayton cycle. Thank you.